Hi everybody, in this video we're going to go over the topics from last week. We're going to review marking diagrams and drawing valid conclusions, and then we're going to talk about some important angle relationships in geometry. So in this example here, we're told that angle LOP is a straight angle, so I'm just going to mark that in my diagram. We're told angle LOM is a right angle, and that's already marked for us with the box. And we're told that the measure of angle NOP is 30 degrees. Let's think about other conclusions that we can draw. Well, if we know that angle LOM is a right angle MOP also needs to be a right angle. The reason for that is since angle LOM and angle MOP form a straight angle together, are supplementary together, they need to add up to 180 degrees. So if this one's already 90, then this one has to be 90 to make the 180 degrees. Not only are angle LOM and angle MOP supplementary, they are also adjacent. Adjacent angles, let me define that at the top over here, are angles that share a vertex and side in common. So for example, this angle and this angle share this vertex and this side in common. You can think of adjacent angles as angles that are connected to each other, right next to each other, or touching each other. Notice how this angle and this angle are right next to each other or connected. When we have two angles like LOM and MOP that are both supplementary and adjacent, we say that they form a linear pair. I'm going to write that down. Angle LOM and angle MOP form a linear pair. Once again, a linear pair are two angles that are both supplementary, they add to 180 degrees, and adjacent. They are connected, attached, or right next to each other. Now that we've justified why this angle needs to be 90 degrees, since we know that this angle is 30 degrees, we can then conclude that angle MON is 60 degrees. Angle MON and angle NOP together make 90 degrees. 60 plus 30 is 90. So we can say that these two angles are complementary to each other. Remember, two angles that are complementary to each other add to 90 degrees. One last conclusion, and there's more that we can draw, but one last one for the slide before we move forward. We can say that ray OM, notice how this ray is going in the M direction, that's where the arrow is facing. So I can say that ray OM is perpendicular to line LP. Remember, perpendicular, and that's the symbol for perpendicular. For those of you who haven't seen it, I'm going to just put it over here. So remember that perpendicular lines form right angles. And since we've already shown that right angles are formed where ray OM and line LP meet, we know for sure that they are perpendicular to each other, that the statement is true. Now that we've talked about what it means for two angles to be adjacent to each other, see if you can find two angles in this diagram that are adjacent. I found angle A and angle B, angle C and angle D, and angle B and angle C. Once again, adjacent angles are angles that share a vertex and side in common. We can think of them as connected or attached to each other, right next to each other. A is right next to B, they're connected, common vertex and side. B is adjacent to C, they're connected, they're attached, vertex and side in common. And C and D are connected, they're attached, vertex and side in common. If we add up angle A, B, C, and D, as you can see from the marking here, they're all coming out of this straight angle, this 180-degree angle. So if we put all the angles together, we should get 180 degrees. We should get the entire straight angle. So we can actually say that angle A, angle B, angle C, and angle D are supplementary. Once again, angles that are supplementary are angles that when you take them all together, they add up to 180 degrees, a straight angle. So in this diagram, we have two intersecting line segments. We have line segment AEB, and we have line segment CED. And when these two line segments intersect, they form four angles. As you can see here, they're labeled angle 1, angle 2, angle 3, and angle 4. So we're going to try to think about which angles in this diagram for sure have to be congruent to each other. So in order to better illustrate this, I'm just going to make up a number for one of the angles. I'll go with angle 2. Let's say angle 2 is 60 degrees. Once again, I just made up this number. It doesn't give it to me anywhere. Let's illustrate better what's going on. If angle 2 is 60 degrees, what does angle 3 have to be? You might be thinking, well, together, angle 2 and angle 3 form a linear pair, so they need to add up to 180. So that makes angle 3 120 degrees. You might also be thinking that angle 4 would need to be 60 because angle 3 and angle 4 together form a linear pair. So together they need to make 180 degrees. And finally, angle 4 and angle 1 form a linear pair. So together they need to make 180 degrees, leaving angle 1 with no choice but to be 120 degrees. You can try other numbers for angle 2 and figure out the rest of the angles as well using our linear pair relationships that we have here. And you'll see that angle 1 and angle 3 will always be congruent to each other, as will angle 2 and angle 4. Let me erase these markings over here so I can mark the angles. Angle 1 congruent to angle 3, angle 2 congruent to angle 4. We call the congruent angles formed by intersecting lines vertical angles. I'm going to define vertical angles over here. So vertical angles are congruent, non-adjacent angles formed by intersecting lines. So once again, here we have two lines that intersect. And whenever we have two lines that intersect, the non-adjacent angles, the angles that are not right next to each other. So for example, angle 1 and angle 3, they're non-adjacent. They do share a vertex, but they don't share a side in common. Angle 4 and angle 2, they're non-adjacent. They do share a vertex, but they don't share a side in common. They're not right next to each other. In fact, they look like they're opposite or across from each other, which is a really nice way to think about vertical angles. And the nice thing about vertical angles is that vertical angles are always congruent no matter what. So when we see vertical angles in our diagram, we get really excited because we know for sure that they are always congruent to each other or equal in measure. You might want to take a second and pause the video and try to set up and solve the next one on your own. Notice how there is no diagram given to you in this example. So using the information given in the situation, you should make your own diagram and you should label it according to the question. Anytime a question doesn't have a diagram, a great approach in geometry is to draw your own diagram. So we know that AB and CD are line segments. I see the notation on top. And I know that they intersect at point E. So let me draw that. I'll just make this line segment AB. It doesn't say which one's which. It doesn't matter. I'll make this one CD. And the point that they intersect at is point E. There we go, diagram all done. Now we just have to label it. That was easy. Measure of angle AEC is 6x plus 20. Measure of angle DEB is 10x. What is the value of x? Let's find it. Notice how these two angles that we have information about are formed by intersecting lines. They're non-adjacent. In fact, they look like they're across from or opposite from each other. That's what vertical angles are. And we know that when we have vertical angles, they are always congruent to each other or equal in measure. These two vertical angles would be congruent to each other, as would these two. But we're not interested in these two. We don't have any information about them. We're not looking for them. We're interested in the value of x, which is talking about these two angles that we have information about. So let's make an equation that says what we just said out loud, that these two angles are equal or congruent to each other. This angle, the 6x plus 20 angle, is equal to this angle, to the 10x angle. Let me solve real quick. And last step. There we have our x value. The question just asked for the value of x. It didn't ask us to plug back in to find any specific angle measurements, but definitely make sure that you pay attention to what the question is asking for so you make sure to get the question correct. Here we have angles at a point. So notice in the diagram on the left, it looks very similar to the vertical angles that we were looking at before. There are vertical angles here, angle 1 and angle 3, angle 2 and angle 4. And notice how all of the 4 angles here come out of the same point E. They all share the same vertex, vertex E. If we take together angle 1 and angle 4, we know they form a linear pair, so that's 180. If we take together 2 and 3, we know they form a linear pair, so that's 180. 180 plus 180 makes 360 degrees. Over here, we have 3 different angles that come out of the same point. But if we take them all together and add them up, we should still get the full circle or 360 degrees. Anytime we have angles that come out of the same point, when we add all of the angles up, it should add up to 360 degrees. Let's do some practice examples. Notice here, intersecting lines, non-adjacent angles that look like they're across from or opposite from each other. That's vertical angles, and vertical angles are always congruent. So I know the x plus 5 degree angle is equal to the 2x minus 5 degree angle. Subtract x from both sides. Add 5 to both sides. And we have our answer. The next one's a little bit trickier. We're told that angle 3 is 60 plus 30, and that angle 2 is 80 minus 60. We need to find the degree measure of angle 4. Angle 3 and angle 2 are not vertical angles. They're not non-adjacent. They're actually adjacent. They're right next to each other. And you might notice that they're supplementary. So together they form a linear pair. They make 180 degrees. So my equation needs to say that this angle, the 60 plus 30 angle, angle 3, plus angle 2, the 8t minus 60 angle, together make 180 degrees. Combining my like terms, adding 30 to both sides, and then finally dividing both sides by 14. We have our t value, but we're not done. The question wanted the degree measure of angle 4. I know angle 4 and angle 3 are vertical angles, so I know that they're congruent to each other. If I take my t value and plug in for angle 3, since angle 3 and angle 4 are congruent, that will give me the measurement of angle 4. That looks a little weird. Let me rewrite that. Now I've plugged in my t value to the expression. Let's take a second and evaluate on our calculator. We have 15 times 6, 90, plus 30, that's 120 degrees. And that tells us that angle 4 is also 120 degrees. Vertical angles are always congruent. In the diagram below, ray JK bisects angle LGM. Recall that an angle bisector splits an angle into two congruent parts. So since this angle is for sure being bisected, it's being split into two equal parts. So I can make an equation that says this half, the 6x plus 2 half, is equal to this half, the 8x minus 6 half. Subtracting 6x from both sides, and then adding 6 to both sides. Finally, dividing both sides by 2, we have x is equal to 4. We were asked to find LJM. LJM, that's the whole big angle, LJM. So let me plug in and figure out what the whole angle is. So we have 6 times 4 plus 2. 24 plus 2, that's 26. Since this is a bisector, this half should be the same, 26. 26 plus 26 makes 52. The whole angle, so I should write measure of angle LJM, is equal to 52 degrees. The measure of two complementary angles are represented by 3x plus 15 and 2x minus 10. What is the value of x? Complementary angles mean that they add to 90 degrees. So I can make an equation that says the 3x plus 15 angle plus the 2x minus 10 angle together make 90 degrees. And I'll make a note of that. Complementary angles add to 90 degrees. Combining my like terms, 3x and 2x is 5x. 15 and negative 10 is positive 5. Subtracting 5 from both sides, gives us 85. And now the last thing we have to do is divide both sides by 5. And I got x is equal to 17. Now we're getting a little bit more difficult. This is the last slide we're going to do for today on angle relationships, on our new angle relationships. So we have line segment CED, we have line segment AEB, and we have line segment EF. We need to find x and y. So let's think about what we know for sure. The first thing that's jumping out to me is I know that angle AEC, the 68-degree angle, and angle CEB, the angle labeled y degrees, together make a linear pair. They are supplementary and they are adjacent to each other. So if this angle is 68 degrees, the angle labeled y degrees would be 180 minus 68, which would give us 112. And already we found our value of y. That's all done. Now we just need to think about how we are going to find x. So I do also know this, that since we have intersecting lines here that come out, and we have angles sharing the same point, when we have intersecting lines, remember that the non-adjacent angles that look like they're across or opposite from each other are vertical angles, and vertical angles are always congruent. So here, the 68-degree angle and angle BED are congruent vertical angles. They're non-adjacent angles formed by intersecting lines that are congruent. They're across from each other, opposite from each other, congruent to each other, vertical angles. So I know that the 68-degree angle is the same as both of the parts of BED put together, as this whole angle here. 4x minus 2, that's one part, plus 30, that's the other part. Put them together, it should be the same as the 68-degree angle. Now that I have my equation, let me combine my like terms and solve. 30 and minus 2 is 28. Subtracting 28 from both sides, and then dividing both sides by 4. We have our x value is 10. So now we have found our x value and we have found our y value using our new angle relationships. So just a short recap. Adjacent angles are two angles that are next to each other or connected. They share a vertex and a side in common. Supplementary angles are two angles that add 180 degrees. When angles are both supplementary and adjacent, like these two angles here, we say that they form a linear pair. If we have two angles that add to 90 degrees, we say that they are complementary to each other. And finally, vertical angles are angles formed by intersecting lines that are non-adjacent, like these two angles here. And vertical angles are always congruent to each other. Let's take a look at this next example over here. We have BD bisecting angle ABC. If BD is a bisector of angle ABC, remember a bisector means cut into congruent parts. So we know that angle ABC is being split into two equal parts, angle 1 and angle 2 being congruent to each other. Let me write this down. So I'm going to just label it number 1. Angle 1 is congruent to angle 2 because angle bisectors split an angle into two congruent parts. We're also told that angle 3 and angle 2 are vertical angles in our given information here. If angle 3 and angle 2 are vertical angles, we know that they're congruent to each other. Angle 3 is congruent to angle 2. And our reason for that is going to be intersecting lines form vertical angles, and vertical angles are always congruent. Instead of putting this whole justification here that we put, you can simply just say vertical angles are always congruent, because in the given information, they do already tell you that angle 3 and angle 2 are vertical angles. You already know that there are vertical angles, they're formed already, you know that they're there. So you can simply write as your reason for this, vertical angles are always congruent. That's how we know angle 3 is congruent to angle 2. That's our statement, that's our justification or our reason that goes along with it. Our goal, and it appears I got cut off from the screen. So I'm going to write our goal or our proof statement is to show that angle 1 is congruent to angle 3. Take a second and pause the video, and with our markings and the diagram from our given information, try to see if you can explain why angle 1 and angle 3 might be congruent to each other. Okay, so we already know angle 1 is congruent to angle 2. I'm going to write that here. We showed that in our first step. We also showed that angle 3 is congruent to angle 2. They weren't vertical angles. Notice how angle 1 and angle 3 are both congruent to the same angle, angle 2. So let's say angle 2 is 40 degrees. I'm just making up a number. Well, angle 1 has to be 40 degrees because it's congruent to angle 2. And angle 3 needs to be 40 degrees because it needs to be congruent to angle 2. So if angle 1 and angle 3 are both congruent to the same angle 2, what can we say about angle 1 and angle 3? You might be thinking, well, they have to be congruent or the same as well. And that's absolutely true. We call this an example of the transitive property, the transitive postulate, I should say. The transitive postulate says if we have two things that are congruent to the same third thing, then they're congruent to each other. Just like we have here, we have two angles, angle 1 and angle 3, that are both congruent to the same third angle, angle 2. So that means they have to be congruent to each other. So I'm going to write that over here. And I should write that here. So angle 1 is congruent to angle 3. So from our given information and the conclusions that we drew from our given information, we can then say angle 1 is congruent to angle 3 due to the transitive postulate. So what we did here is we actually wrote a beginning proof. It's not in formal proof format because we didn't get there yet, but we actually started to prove a statement together. Let's take a look at what we're given here and the conclusion that we're trying to reach. My bad, I haven't zoomed in too much. I couldn't see the rest of the slide. So this time we're given some information. And from the given information, we have to draw our own conclusion and provide a reason for that conclusion or a justification for that conclusion. So we know angle 1 is complementary to angle 2. Let's remind ourselves what complementary means. That's two angles that add to 90 degrees. So angle 1 and angle 2 are complementary. Together they add to 90 degrees. And angle 1 is complementary to angle 3. So together angle 1 and angle 3 also make 90 degrees. Let's think about the conclusion that we can draw. It's super hard just thinking about this abstractly, so let's make it more concrete with a numerical example. Let's say angle 1 is 60 degrees. Once again, I'm just making up a number. Well, since angle 2 is complementary to angle 1, if angle 1 is 60, that means angle 2 has to be 30 to make 90 degrees. And since angle 1 is also complementary to angle 3, meaning that they both make 90 degrees together, if angle 1 is 60, then angle 3 also has to be 30 degrees to make the 90 degrees. So with this example, we can see that if angle 1 is complementary to angle 2, and angle 3 is also complementary to the same angle 1, angle 1 and angle 2 and angle 3 have to be complementary to each other. Equal to each other. Sorry, I'm messing up my words. They have to be equal to each other. As we see here, they both were 30 degrees. And I'm going to write down our reasons. Since angle 2 and angle 3 are both complementary to angle 1, they need to be the same in order to make 90 degrees with angle 1. And for those of you who prefer to see it written out in mathematical symbols, I'm going to write here angle 2 and angle 3 need to be 90 minus angle 1 in order to make the right angle with it. You'll notice that this holds true if we use different numbers here just to get a better idea of what we're saying here. Let's say angle 1 was 40 degrees. Not drawn to scale because I know that angle 1 looks bigger than angle 2. That means that angle 2 would have to be 50 degrees to make 90 degrees. And that means that angle 3 would also have to be 50 degrees to make 90 degrees with angle 1. So regardless of what number you pick for angle 1, since angle 2 and angle 3 are both complementary with angle 1, they need to be the same in order to make that 90 degrees with angle 1. Here we're given angle 1 complementary to angle 2, so together they make a right angle. We're also given that angle 3 is complementary to angle 4. And we know angle 1 is congruent to angle 3. So let's think about what conclusion we can draw. Let's say, for example, I'm just making up a number, that angle 2 is 60 degrees. Well, that means angle 1 has to be 30 degrees since they're complementary to make the right angle. Since angle 1 and angle 3 are congruent to each other from the givens, angle 3 has to be the same as angle 1. And then there's no other choice for angle 4 to be 60 degrees, the same as angle 2, because together angle 3 and angle 4 need to make 90 degrees. So we can see here that angle 3 and angle 4 have no choice but to be congruent to each other. So we actually have two ways that we can justify this. So first, I'm going to talk about our new way for this week. So as we said here, since Angle 3 is complementary to angle 1. Angle 4 is complementary to angle 3. And angle 1 is congruent to angle 3. Angles 2 and 4 have to be congruent since they are complementary to congruent angles. And I know that's a lot. Let's review one more time what that means. These add to 90. These add to 90. These are congruent. So whatever this is, this needs to be also, because these are complementary to the same angle. We have a shortened way of writing out this reason, and it's the reason we also used in the last slide. We can write complements of congruent angles are congruent. And that completely justifies what we said here in shorter words and fewer words. So once again, angle 2 and angle 4 are complements of congruent angles 1 and 3. So that means they have to be congruent to each other. So instead of writing out this whole thing, we can write complements of congruent angles are congruent. The second way that we can justify this conclusion is through the subtraction postulate, but I'm not going to talk about that now because I don't want it to get confusing. The purpose of this slide and the previous one was to talk about this new theorem. Complements of congruent angles are congruent. Let's take a look over here. We have angle 3 supplementary to angle 4. So supplementary angles together add to 180 degrees. And we have angle 5 supplementary to angle 4. Together they add to 180 degrees. Let's think about the conclusion that we can reach. So let's make up numbers again to see what's going on. So let's say that 3 is 120. I'm just making that up. Since 3 and 4 are supplementary, 4 has no choice but to be 60 degrees to make 180 degrees. Since angle 5 and angle 4 are supplementary, angle 5 has no choice to also be 120 to make 180 with angle 4. So we see here that angle 3 and angle 5 need to be congruent to each other. And let's summarize what we just said out loud with a reason. Since angle 3 is supplementary to angle 4, and angle 5 is also supplementary to the same angle, angle 4, angle 3 and angle 5 need to be the same to make 180 degrees with angle 4. And once again, for those of you who like to see it written out in mathematical terms, angle 3 and angle 5 are 180 minus angle 4 because they need to form 180 degrees with angle 4. Both of them. They're both supplementary to angle 4. here, we're given that angle F is supplementary to angle G. So once again, F and G, they're supplementary. They form 180 degrees. H is supplementary to J. They form 180 degrees. And angle G is congruent to angle J. So I'm going to mark the congruent angles with the same congruence mark in my diagram. So in order to see the conclusion that we can draw here, let's once again use numbers to illustrate to us what's going on. Let's make up a number for any one of these angles. I'll just make up a number for angle F. Let's call it 150 degrees. Doesn't matter. I'm making it up. Well, since angle F and angle G are supplementary, angle G has no choice but to be 30 degrees to make 180. And since angle G and angle J are congruent to each other, if angle G is 30, angle J also has to be 30. And since angle J and angle H are supplementary to each other, if angle J is 30, angle H has no choice but to be 150 degrees, since they need to add up to 180. So we can see here that angle F and angle H need to be congruent to each other. Let's write a reason here. Angle F and angle H are both supplementary to congruent angles G and J. So they have no choice but to also be the same. We have a name for this theorem so that we can write this explanation in a shorter amount of words. We can say supplements of congruent angles are congruent. So what this means in this situation is that since angle F and angle H were both supplementary to congruent angles, G and J were congruent, angle F and angle H had to be congruent to each other since they both needed to be the same value to equal to 180 with G and J. Instead of writing out that whole thing, we can just say supplements of congruent angles are also congruent. Let's take a look at the following examples and let's try to write down why each one is true. In the first example, we're given that angle 1 is congruent to angle 4. And we need to prove that angle 2 is congruent to angle 3. Well, I see one of our new angle relationships here. I see vertical angles. Oops, I shouldn't mark it like that. Angle 1 and angle 2 are vertical angles. Angle 3 and angle 4 are vertical angles. So let's write this down. So we have our givens, and then after our givens, we have angle 1 is congruent to angle 2. And angle 3 is congruent to angle 4. Because they are vertical angles, and vertical angles are always congruent. So now for more markings in the diagram, you might be able to see that what we need to prove is true. Angle 2 is congruent to angle 3. We marked them in the same color. Now we have to justify why. Well, angle 1 was congruent to angle 2, and angle 3 was congruent to angle 4. So why are angle 2 and angle 3 congruent to each other? It seems like it might be the transitive property. But keep in mind, the transitive property is when you have 3 items total. When you have 2 things congruent to the same third thing, so they're congruent to each other. But here we have 4 objects, 4 angles that we're working with. 1 is congruent to 2, 3 is congruent to 4, so then we're concluding that 2 is congruent to 3. Since there's 4 items here and not 3, it's not really the transitive postulate, even though it seems like it probably might be. So we're going to use the more general version of the transitive postulate, which is substitution. Remember, substitution is when we're replacing one thing for something else that's equivalent or means the same thing. So since angle 1 is congruent to angle 4, 1's congruent to 2, and 3's congruent to 4 by substitution, angle 2 is congruent to angle 3. So we can write that down here. Angle 2 is congruent to angle 3 by substitution. Let's take a look at the next one. Ray GE is bisecting angle DGF. That means it's splitting it into 2 equal parts. So I can say angle 3 is congruent to angle 2 because an angle bisector splits an angle into 2 congruent parts. From this information, we need to prove that angle 1 is congruent to angle 2. Well, I see that we have intersecting lines, and when we have intersecting lines, the non-adjacent angles that are opposite or across from each other are vertical angles, which are always congruent. So I see that angle 1 is a vertical angle with angle 3, so they're congruent to each other. Let me write that down. Angle 1 is congruent to angle 3 because intersecting lines form vertical angles. And vertical angles, I'm just abbreviating for lack of space. You should write out the word vertical angles, are always congruent. Then finally, we just need to justify why that means angle 1 is congruent to angle 2. Well, angle 3 is congruent to angle 2. That was our first conclusion. Angle 1 is congruent to angle 3. That was our second conclusion. Since angle 2 and angle 1 are both congruent to the same third angle, angle 3, that means they have to be congruent to each other. Do you remember the name of the postulate that justifies that? If you're thinking the transitive postulate, then you are correct. Here we have 3 angles that we're dealing with. We have 2 angles that are congruent to the same third angle, so that means they have to be congruent to each other. Last one. Angle ABD and angle CDB are right angles. Measure of angle 2 is equal to the measure of angle 4. What we need to show is that the measure of angle 1 is equal to the measure of angle 3. 2 ways that we can do this. We can either use the subtraction postulate, we can take the 90-degree angle minus angle 2 to give us angle 1. And we can take the 90-degree angle and minus angle 4 to give us angle 3. Or we can use one of our new theorems. We can also say angle 1 is congruent to angle 3 because complements of congruent angles are congruent. Angle 1 is complementary to angle 2. They make a 90-degree angle. And angle 3 is complementary to angle 4. They make a 90-degree angle. Angle 2 and angle 4 are equal or congruent to each other. So that means angle 1 and angle 3 have to be the same measurement to make 90 degrees with the other angle. To illustrate it with numbers, let's just say that 2 is 30 degrees. That makes 4 30 degrees as well, since they're congruent. Angle 1 has no choice but to be 60, and angle 3 has no choice but to be 60. So we see that what we said is true. Angle 1 and angle 3 are congruent to each other because they're both complementary to congruent angles. So they have no choice but to be the same as each other, so they could be 90 degrees with the other angle. For those of you interested in what the subtraction would look like, for the subtraction, I'm going to write or, because there's two different ways to justify this. We know that angle ABD is congruent to angle CDB because they're both right angles and all right angles are congruent. So knowing that, we can take angle ABD and subtract from it angle 2. So ABD is the right angle. If we take away angle 2, we're left over with angle 1. And if we take angle CDB and we subtract away from it angle 4, we're left over with angle 3. Our subtraction here works because we're starting with two congruent things. Angle ABD and angle CDB are congruent right angles because all right angles are congruent. And we're subtracting two congruent things. Angle 2 is congruent to angle 4 because we're told that in the given information. That's the subtraction postulate of congruence. We can replace the subtraction with what it actually is. We can say this minus this is this minus this is this by the substitution postulate. So this would be subtraction, and this would be substitution. Take a second, pause the video, and try to answer the questions here. And then the answers will be displayed. Here are the answers with reasons and justifications. The first one, we can use the addition postulate because we're given information that is smaller than the angles that we want to end up with. So we need to combine the two smaller pieces of each angle to make the bigger angle that we're actually interested in making a statement about. In number 2, we have supplementary angle relationships. We have linear pairs. So we can use our new theorem that says supplements of congruent angles are congruent. You might want to take a second and pause the video so you can read through the explanations and make sure that you understand them because the video is about to end.